Welcome to my Bash final project presentation about domain reconnaissance. Today there's an increasingly large number of threats in the cybersecurity landscape, and one of the largest parts of that landscape that is a significant threat is the threat of phishing. So phishing can be defined as, messages including links that are illegitimate, sent through email, text messages, social media, and more than that. It can also be, fake emails that, respond to this email with your social security number because the the system lost it or something like that. But in this case, I'm talking about illegitimate links that appear to the untrained eye to look like they're sent from a real corporation or government agency. So, for an example, Google instead of google.com, which is the legitimate domain, or micro0ft.com instead of microsoft.com, which is the legitimate domain. So, especially for individuals who are not as up to date with the increasing number of threats that you have to deal with when you're online. Um, Phishing is a significant problem because they might not know what to look for, or you know look for in emails or when you're clicking on websites. Especially in businesses, this has been an increasingly large problem because you can train people, but oftentimes, they're working 8 hours a day, and at the end of the workday, they might be checking their email, and might assume an email looks fine and click on a link, and something bad happens. And especially a big example of that um, happened recently. Cloudflare, there's a scam essentially going around where illegitimate sites, look like they're using Cloudflare to determine if a user is real or not. Um, but this prompt asks them to run a command on their computer. Now, you and me might know that that is not legitimate, but person who might not know might do it. So that's a big problem, especially if they're not trained in kind of what to look for. So there's a couple different methods for determining if a domain or website in general terms is valid. So, and we don't necessarily have to use all of them, but these are the few that I used, and there's way more tools out there that can be more specialized. But my couple things with this project were essentially to just use tools that were recently supported, or have had updates recently, or and tools that aren't super heavy on your system, as in they're not gonna be have a bunch of different packages that they require to install. Since we're planning on running this on a Linux system, I kind of want them to be able to run on anything. So just a rundown of what each of the different tools does. So whois essentially just querying the whois records of the domain, which essentially means who owns this domain. OpenSSL essentially does a similar thing. It just checks, or the way I have it set up is it just checks when was this domain registered, which is a good check to check, is this domain valid? So if something's registered in the last year and it's like google.com, or it looks like google.com, that's probably not a legitimate domain. Google's existed for a long time, so they probably didn't register their domain name within the past year. Amass essentially looks up um, the subdomains, or kind of performs an enumeration of the domain, which is a fancy way for saying it just kind of figures out what's in it almost. So that looks, in my case, it looks for subdomains. So, if I were to enter google.com into my tool, I would end up with drive.google.com. And that's kind of a way of saying, okay, this is probably legitimate. If this was a spam or a malicious site that was trying to impersonate Google, would they have gone through the links to replicate all the subdomains that Google has, like Drive or Photos? And then DNS Twist is essentially performing what the rest of the script does, but almost in reverse. So if I enter google.com, um, you know, which is a legitimate domain, this looks for all the other domains that kind of look like google.com but aren't google.com. So going back to that second slide is like google.com. And then iPerf3, since this test uses some network and can take a long time, especially a mass and DNS twist. A mass takes a while, manually running through and checking each of the domains, and DNS twist also takes a while because it's looking through the entire registry. And there are ways that you could speed that up, like you can get an API key from certain sites that let you query it. But I wrote this as, okay, this is probably just going to be run every once in a while, and if they want to, it's a very simple thing. All you have to do is just, in the amass command, you basically just put in a link to your config.ini file, and it pulls the API key out of that. But the way I wrote this, I wanted any user to just be able to clone this, put it on their machine, and it automatically installs the dependencies, except for amass, since that can be a little bit different on system to system, and then be able to run. So as I've kind of talked about here, my solution is just to develop a batch script that can be used to determine the validity of the domain. So in a couple steps, we check the network speed essentially by flooding a bunch of packets through it. So once every second, it sends like 200 megabytes to it just to test that it can handle a sustained load, which is important for this, as if we do not have that, then we kind of have issues with it. So if like for some reason the network goes down during that test, the user could see that and go, oh, well, I shouldn't be running this. My network isn't powerful enough. And then we go to Whois, which just retrieves the results of who owns the domain, etc. Where is it registered? With what registrar? So like I have a personal domain, and that's registered through GoDaddy, and you can, and that'll show, okay, GoDaddy has this, and then OpenSSL comes along and just puts in, when was this registered? So obviously, I mentioned before, if you're looking at like Google.com or Microsoft.com, you see something registered within the past year, you're like, you should be concerned. Oh, that's probably not legitimate. Microsoft has owned that domain for a long time. So they probably wouldn't have registered it within the past year. And then we use amass to determine if there are any subdomains of the main domain, which is also important just to see, like, Google.com should have drive.com, photos.google.com, all sorts of that stuff, which will be helpful to determine if it's valid, because a malicious actor probably isn't going to replicate. Google has hundreds of products, each one of those domain records. And then we use DNS twist so if we have entered a valid domain, it essentially performs a reverse lookup of just looking through all the potential malicious domains. So like, as I mentioned, GOOGLEE or GOOGLE.com. And then those results are saved to a file. Looks like my text got a little bit cut off there. Each one of those, so the domains, the subdomains, and the um, the DNS twist results are saved into text files, so the um, person running the script can go through it and find the stuff that they're looking for. So this tool could be improved by using an API key, by making it easier to access the information more quickly. This version doesn't use an API key and takes a bit longer, and therefore I just built it this way because as I mentioned before, just wanted people to be able to download it and use it. In this case, but you could, if you were in a corporate environment, it's very simple. Literally less than a line of code needs to change to add an API key. And then another way this could be improved is parsing some of the output files a little bit. I could have done that in this case, but I felt that it was kind of helpful to just see the whole thing versus the smaller bits of it. And obviously there is a lot of text in there, so there could be some issues with parsing specific lines. Yeah. Thank you for your time. The example will be right after this. And then I'll just walk you through the code real quick. I'll show you the example of, change this to this window here. Nope, not that one. This one. So if I pop this up, you'll see there's a couple of files here. So this is your results folder. It's grayed out because I've added it to the git ignore, so it doesn't commit that to the repository every time. So first thing the script does is it installs the tools that it needs. So we check if we've installed Whois, DNS Twist, and iPerf3. And Amass can't be installed here because it was on Snap, but it was an older version of that, and obviously Snap does not work on all systems, so you'd have to manually install it before you use this, but that's the way I've done it. That could obviously be improved. You could manually install it, and then we check then we create our directory of results here. So we don't have a bunch of just random text files floating in your main directory. You have this results directory. And then you take, typically this is something I like to do, is I just like to bunch everything in these file variables just because I have a feeling I'm going to make a mistake somewhere where I'm writing it. You know, if I'm writing down here domain file and I make a typo, it's going to create another file or something, or say that file isn't found. So I just make the variables here, print our title, and then the first thing we do is we check if iPerf can connect. And what we do is we ping 1.1.1 is Cloudflare, the DNS resolver. So we just check that, and that runs. Well, first thing we actually do is we check if we have internet. That isn't iPerf3 there. I misspoke. So we check if we have internet. So by pinging 1.1.1, which is our DNS resolver. If it doesn't do that, we go down here and we just say, nope, there's no network connected, can't proceed. Then we do our network stress test. We check if iPerf can run for 30 seconds. And then we kill iPerf after that because it does occasionally like to run in the background. And then we ask the user to enter a domain. We check our domain legitimacy here. So we've stored the Whois results to a variable. And then we check, hey, is that variable empty? Because otherwise this is going to be kind of pointless to the user to just go, oh, we found this domain and there's nothing in the file. So no domain results have been found if there's nothing in the file, and we print that to the console as well as log that to the file, and we get our results here. We, if there is any, and then we add them, we print them to console as well as to that log file. And then we check our domain legitimacy, and that is appended. This is OpenSSL that is appended into that domain results folder, which I'll show you in a second, or that domain results file, rather. I'll show you that in a second on example run. Do the same checking, seeing if it's empty. And then we take our subdomains. We use amass. So the first command that we're running here is enumerate. So we're checking what domain, essentially enumerating the domain. And this active flag here, the D is domain in this case, and then I've used the domain variable, but we had the user enter. And then we take this active flag, physically connects to each of those subdomains to check if they're active. So the thing about this is it does cause the script to take longer. But if you want it to not do that, you can just delete that line. And the V is just verbose. So what this does once this enumerate is done is this is built using amass, essentially a database. So the benefit of this is amass does not need to go every time the user runs a command, does not need to go back out to the internet and go, oh, tell me about this domain again, or tell me about this, tell me about that. So we use the subs command, which is the subdomain, and we get the names of those, and those are both printed and added to that subdomain file that we had already mentioned. So we check, if there is a file there. So if there is no file, then we do not, but there's nothing in the file, then we just print no subdomains found, add that to the file. Rather, if there's nothing in that, in this command here, that then checks this here. So if there's not anything in there. And then we also check for any similar domains, and this is using DNS twist. We just use our registered flag there, and we use that domain value, and then we do the same check if anything is found in there. And then just to get a look at some example results here. So this is google.com. So you can see at the top of domain results here, I have google.com, updated date, creation date. So this is helpful here. And then you can also see some of the SSL stuff down here. And then I believe this is actually old, so ignore that. But you can see this is when I go through subdomains. Sorry about that. So this is all the subdomains in google.com. So you could see sites.sandbox.google.com. Google does make Google Sites, so that would make sense. Firebase.google.com, that's something they make. Discover, that's something they make. And then phishing prevention results, sorry about that. This is using DNS twist. So essentially what we've done here is we take the domain here and we just go through, and you can see it's finding all the things that kind of look similar to google.com. So with all the special characters, all sorts of stuff like that. And it also shows you where those are registered. So Google domains, let's see, lots of Google domains. All right. Thank you very much.